If you go on the web, and I might add, if you read some of the manuals that were used to train that pilot who's flying you across the Atlantic, it's wrong. Now, fortunately, the fact that the pilot doesn't understand how the aircraft stays in the air doesn't matter. He doesn't need to, right? He just needs to control the thing. The fact that he doesn't understand the physics is actually irrelevant, which is good, because in many of these manuals, the thing is wrong. Okay? And here's the explanation you'll get. And this was just taken from the web. It's a standard explanation. I believed it for many years until someone sort of pointed... Actually, the guy who pointed out the error of my ways was a guy called Jeff Raskin, who was the guy that really did invent the Macintosh back in the early days. And he was a keen amateur sort of flying sort of person. He built lots of model aircraft. And he pointed something out to me that made me think, oh, yeah, of course it doesn't work. Here's the explanation you get. Here's a wing, nice aerofoil shape. And the air's coming along, and the air gets forced above or below it. Okay? It's got further to travel at the top than along the bottom. And certainly wings are shaped this way. So it's got further to travel, so it has to travel faster. It travels faster, so you've got lower pressure Bernoulli, and it lifts up in the air. Okay, that's the standard explanation you'll find all over, including the basic physics that they teach in many cases at flying school. Okay, so it says airflow is slow underneath the wing, therefore the air pressure is greater than higher. How many people have read that and found it was convincing? I did for many years, yeah. Okay. Okay, so if you believe that, you better explain that. Aircraft can fly upside down. Even a 747 can fly upside down. They don't do it very often, but aircraft can fly upside down. Why doesn't that thing just start to descend rapidly? Well, at that point, you ask yourself, and this is what Jeff Raskin said. He says, look, I'll take you out in the backyard and we'll take a modern plane and we'll see it flying upside down. So forget that one. Okay. Here's the flaw in the argument. Imagine two molecules coming along, two molecules of air, one above the other one, and they reach the wing. One goes up, then the other goes down. Why do they want to meet at the other end? Why does the one at the top speed up and say, oh, if I don't speed up, I won't meet my friend? Come on, these are molecules of air. It's just going to get there later. There's no reason to speed up. People like to speed up if they want to stay together, but molecules of air don't want to speed up and come back to the end. There's not some quantum entanglement or something going on here. There's no reason at all why that should happen. And in fact, it doesn't happen. Okay, so this is completely spurious and bogus, right? That's not what's going on at all. Convincing argument. As I say, it was a long time until Jeff pointed out, oh, God, yeah, there's no reason why those molecules should come together. Doesn't hang together. Now, there's a story you can tell sort of like this, and you can certainly tell a Bernoulli story. It's not that Bernoulli doesn't apply, it's just that the standard story that you'll find all over doesn't work. Here's what really goes on. It's Newton's second law. Every action has an equal and opposite reaction. You design the plane, in fact, it's not just the wings, it's the whole darn plane, and you tilt the plane up slightly so that the air is forced downwards. There's a net flow downwards. And if the air is forced downwards, there's an equal and opposite reaction. It's just Newton, Isaac Newton, and the plane has lift. So the main force is just designing it so that the air goes downwards. And there's actually when you see a plane in level flight, it actually has a very slight angle. And here's also taken from the web, but from a much better website. I think this is taken from NASA's website, and they should know. Is there anyone here from NASA? No one here from NASA tonight? Okay. That's a pity, actually. Okay. All right. I'm pretty sure this was... NASA has a really good website on what does keep things in the air. It's all to do with this angle of attack and so forth. So the reason the plane can fly upside down is that plane that was upside down, it was still angled upwards. And so air was being pointed downwards. So it wasn't something fancy out of the 18th, 19th century to do with Bernoulli's equation. It was good old Isaac Newton in the 17th century, equal and opposite reactions. What happened to that? Hit the wrong button. Okay. Well, I don't want to leave you having sold you another bill of, another piece of junk. All of these two-dimensional pictures are just misleading because lift is a three-dimensional phenomenon. If you just look at the two-dimensional slice, you can tell nice stories, but they don't really work. It's really pretty darn complicated. And you've got to look at three-dimensional phenomena. So it's a three-dimensional phenomenon, but you do need mathematics to understand it. It's just that simple mathematics doesn't work. Okay, that's